Okay, let's look at this question here. Environmental noise. Two neighbors who live 1 mile apart hear an explosion while they are talking on the telephone. One neighbor hears the explosion 2 seconds before the other. If sound travels at 1100 feet per second, determine the equation of the parabola on which the explosion was located. Okay, so to understand what to do on this question, we actually have to back up and understand what the definition of a of a hyperbola is. Okay, so let's assume that our hyperbola is horizontal. So this is what it kind of looks like. We have a horizontal hyperbola. And we have a focus. We'll put the focus here. We have another one here. And so what we're saying, the definition is the difference of this distance and this distance, we'll call this D1, and this is D2. The difference of D1 minus D2 is the same anywhere on the hyperbola. So if I took another set of points, say this one here and this one here, then we'll call this, instead of D1 and D2, let's just call it P1 and P2, okay? Then this would be P1 is equal to P1 minus P2, okay? And what I really should do to really illustrate this clearly is I really should put these in absolute value bars, okay? And the reason why is because when we talk about distance, it's always positive. In fact, if you look at the way I drew it, it looks as if D2 is actually longer than D1. So the way this picture looks, without the bars, this value right here would come out as negative. Okay? So keep this in mind. Okay? This is a technical definition. So let me draw another one. Okay? So here's a hyperbola again. Again, this is F. And this is F. Okay? So these are their foci. Okay? Now, if I look back at this picture, randomly I chose this point here, and then again randomly I chose this point. Okay? But I can actually choose another point. I could actually choose this point here. So this distance from here to here, the difference of this distance and this distance would be equal to D1 minus D2, the absolute value of D1 minus D2. So let's think about this for a second. We know that, again, I'm talking about, I want to know that this is, I'm going to call this D1, and I'm going to call this D2. Okay? So the absolute value of the difference D2, I'll just write it as D2 minus D1 just to be clear, right? This distance here is going to be longer, so this will give me a positive result. Okay? This is what the definition of hyperbola is. Okay? But what is D2 minus D1? Well, let's think about this for a second. So I know the distance from here, from the center to the vertex, that is A. So this distance is A. And I also know the distance from the center to the focus is C, right? So this gap right here, maybe I should change the color, this gap right here, in orange, is going to be C minus A. It is the difference between these 2 points, C minus A. Okay? So what does that mean? Well, what this means is, keep in mind, D2 is this distance from, let me do this in a different color here. Let's go with brown. The distance of D2 is from here all the way to here, right? Well, this distance is going to be, from here to here is C, right? This distance is C. And then we said the distance from the center to this point here is A. So D2 is C plus A. Okay? The distance of D1, is going to be what? Well, I just finished telling you that it's C minus A. So this is parentheses C minus A. Okay? What is this equal to? Well, if I solve this, this is going to be c plus a minus c plus a. In other words, I simply distributed this negative sign into both of here. Okay. Well, if I clean this up a little bit, we're going to notice that the c's, c minus c is going to be 0, so all I'm left with is 2a. So what I've told you now is d2 minus d1 equals 2a. Okay? So that relationship is always true, regardless of whether I'm talking about in this flat situation here, or if we go in this situation here, where we're talking about more of a higher or lower point, right? These are all, this is 2a, this is also 2a, they're all the same, okay? So I had to go through and talk about that because I have to use that to solve our problem. Now, what is our problem here? Well, our problem is this. We have a picture here. We have two neighbors that are apart. We'll call it neighbor A and neighbor B. You can call it whatever you want. Neighbor A, neighbor B. And it tells us in the question that the neighbors are, I believe, 1 mile apart. Now, that means that this distance from here over to here, this distance here is 5280 feet. So you have to know that 1 mile is equal to 5280 feet. Okay? So if that's true, then I know that half of this distance right here is half of 5280. So if I divide 5280, that's what, 2640? So this is 2640, and this is 2640. Right? Okay. So we have these two distances. Now, if you read this question carefully, I mean, it does immediately tell you that you're dealing with a hyperbola. Okay? But it also says this: one neighbor hears the explosion 2 seconds before the other, right? So what that actually is telling you is that A and B are the focus of my hyperbola, and so my hyperbola is going to look something like this. Okay? That means the explosion occurs somewhere on the hyperbola. Okay? And what actually is going on here is this distance from here to here, the difference of this distance here and here is the 2 seconds, right? And that's what you have to decipher. That's actually how you know it's a hyperbola, because it is the difference between those distances. Okay, so now that we have that, what does that tell me? Well, we also know, and it's kind of hard for me to see here, so I'm going to erase this a little bit just so you guys can see, but I also know that sound travels at 1100 feet per second. So if I travel 2 seconds, that means that this distance, the difference of this distance and this distance here, is going to be 1100 times 2. Times 2 because it's 2 seconds, right? So this is 2200. Okay? So this is 2200. And what does 2200 equal to? Well, what did we say is the difference between this distance here and this distance here? Well, let's look back. Remember earlier, we defined it. We solved it right here, right? And we solved it to be 2a. So this is just simply equal to 2a, which means a is equal to 1100. Okay? This means that if I look at my picture, this distance here is simply 1100. Right? As with this distance right here, be 1100, right? The distance from the center to the vertex is 1100. So now I have A on my hyperbola. Okay, awesome. Okay, what are A and B, right? Well, we just finished saying that A and B are the foci, right? So if they're the foci, the distance from the center to the foci, which remember we said is 2640, that is actually C. Okay, this is awesome, because we know that a squared plus b squared equals c squared, right? That's the formula that we've talked about that tells us the relationship between a, b, and c, right? That's the relationship between the distance from the center to the vertex, the center and the focus, and then our b value, which goes up here and down here. Okay. So then, if I need to solve this, well, I just told you a is 1100, so it's just going to be 1100 squared plus b squared is equal, and I just said c is 2640, is equal to 2640 squared, which then gives me b squared is equal to 2640 squared minus 1100 squared. And whatever that gives me, that's going to be my b value. Okay? So if you type this in the calculator, you get roughly 2400. Okay? So what does that tell me? Well, if the formula, let's just do this on another page here. If the formula, remember I drew my hyperbola as a horizontal one, and the only reason why I drew it as a horizontal was because that's the way I thought of it. You could have drawn it as a vertical, it didn't matter. But as a horizontal, the formula is as such, right? So now all I got to do is go back here. I know my b value is 2400. I know my a value is 1100. So this becomes x. Now keep in mind too, right, if we look at this picture here, the way I drew this, the center is 0, 0, right? So hk is just going to be 0, 0. So this is just x squared over a, which again, remember a is just 1100, plus y squared over b, when we calculated b to be 2400. And this equals 1. Okay, so this is roughly what the answer is. Okay, if you'd like, this is another picture that I drew of representing the situation. This may be a little clearer visually to see how this looks. So this is different software that I used to solve it originally, and you can see my work. By the way, my answer may be slightly off from what the answer key may say, just because I rounded 2399.91 to 2400. Okay, but this is essentially what my answer is going to be. Okay, so hopefully that makes sense. Again, I think really the key to understanding this problem is you actually have to understand what the definition of an ellipse is, which is anywhere from the focus to the center and the focus to the other center. These distances, the difference of these distances is the same anywhere. And from that, we decipher that the difference is the equivalent of 2a, and from that, we decide we can use that to solve the problem. So that's a lot to digest. Hopefully that makes sense, and I'll see you guys when I see you guys.